Hello everyone and welcome to my video. In this video I am going to teach you all what you need to know to get started in API backend development in Python. Before watching this video, if you are not familiar with SQL, I truly recommend you to watch my playlist. It starts from zero and covers all what you need to know. It goes to an advanced level and it starts from the beginning. So in order that you will understand everything in this video, I truly recommend you to go and watch the SQL playlist I have made, and I am still going to upload new videos into this playlist. And without talking too much, let's start. So take a look at this image. As you can see, this image shows us what an API is. So we have the client. The client is the actual UI and the actual website itself. And then we have the backend, which is our server, or so-called an API. The API accepts a couple of methods, such as getRequest, postRequest, put, and delete. We will go over each one of them. But the main key point is that the actual thing, the actual responsibility of an API is to go to the database, pull data from the database, and send it into our client. So let's say that you are in a website which has a lot of data and you requested a certain entity. Then you communicate with the web server, which is in our case the API. The API goes into the database and gets the certain entity you have requested, and then it sends it into the client. So as you can see here, we send the request, and then we go into the API. The API itself communicates with the database and then sends the response from the database into the client. So as you can see here, we have our first method, which it is just a GET request. And as you can see, we communicate with the database, we do select all from todos, and then we send the response into the client. So if our client would love to go and get all the to-dos we have in our database, he will request this API. But first of all, we should create a table, so we can create the to-dos table. So we can do create table to-dos. And let's open the brackets. And the first column is going to be ID serial primary key. And the second one is going to be title. And the last one is going to be description. And it is going to have a type text as well. Now we can go into the beaver and then execute this. Let's do select all from to-dos. Okay, and as you can see, our table has been successfully created. And now let's try to insert our first to-do into this table. So insert into to-dos, and then we can specify the columns and also the values we are going to send. So now we will specify the values. The first to-do's title is going to be my first to-do, and the other value, my first to-do description. Okay, now I will execute this, and now I will select all from our table again to see if the data has been inserted successfully. Even though that it says that everything is good here, I'll have to take a look. Okay, so now we can move on. So before, I've been telling you that the API communicates with the database and then sends the actual data, so I will emphasize it. This is Postman. It allows us to interact with the backend. As you can see, I am using it quite a lot. Those are all the routes. And in order to communicate with our API, we should specify its route. So we are running on localhost port 8000. So we can specify it. Let's take this route and just modify the actual URL of this. 1 second. Okay, let's put the appropriate port. And now we can put the rest of our route, which is this. But before sending the request, we should turn on our API. So let's do Python API to turn it on. And now let's execute our first request, which is a GET request, which allows us to get our to-dos. So as you can see, I specified here that the request is going to be GET, and this is our route. So in our request, we specify the HTTP method and the relevant route. And as you can see, here is our data, which is exactly what we were requesting here. Select all from todos. Okay, before I continue, I would love to go over the code and explain about what is going on here. So first, we should start with the database file. As you can see, I call this function, the get database connection from our database file. This file and this function specifically is responsible for initializing a connection into our Postgres database, and it uses those credentials from our constants.py file, which just has static variables, which allow us to connect into our Postgres database. So as you can see, I am importing it here, and then I call it here in order to communicate with Postgres, and then the cursor object has a couple of methods such as execute, which allows me to execute SQL commands. And then I send the actual response from the database and its status code. As you can see right now, I am inside of the Postgres shell. And if I go here and see our database name, it says that we are working inside of the systems database. So we can do L in order to display all the databases. And then we can go into this database. I will clean the terminal, and then we can do display tables /dt in order to display all the tables, and we can do select all from users in order to see, not from users, this is not the correct table, I'm sorry, select all from todos in order to see our data here directly in the database. So when we are using an API, all what we do is communicating with the database. So we can go back here. As you can see, the moment I send the GET request, the API communicates with the database itself and then pulls all the data. And as you can see, this data is exactly the same as here, but we are just using the command in order to get the to-dos in our API instead of using it directly inside the database. So as you can see, I can do select all from todos, and this is the exact same command I am using inside of my API. Okay, so let's explain about this part. As you can see, we have try and except in our function. Try and except makes sure that whenever we have an error, an unknown error, our program will not terminate. This is a must thing when working in backend development, because that if we wouldn't use try and except, our program would have been terminated every time there is an error. We call finally in order to close the database connection. Once we send a response to the client, we don't have to keep the database connection open. Therefore, it means that we can just close it in order not to waste any resources in the server itself, because that if the database connection will always be open without a reason, it is just going to waste a lot of CPU and memory usage, and we don't want it. Okay, and then we have this section. Here, basically all what we do is debug true. It means that if we change the code, our API will refresh immediately without me having to turn it on again. For example, turning it on again means that I will have to terminate the program and do Python api.py again in order to turn it on. But here, since we have debug true, I don't always have to do it. The changes will reflect immediately. And then we have our host, which is localhost. It means that our API is going to be running on localhost, and then we specify our port, which is port 8000, as you can see here. Okay, after all of that, now we can continue with our API. Now we are going to make our second route. So what we can do is to copy this chunk of code, because there is a lot of repetitive code, so we don't have to write it again from scratch. And now I will change it to get a specific to-do. So now I am not going to get all the to-dos, I am going to get a specific to-do. First of all, I will add a couple of more to-dos, so I can do insert into to-dos. and I will insert data again, title, description, and then specify the values. Second to do, and second description, we can call it. Now let's execute it and insert our third to do. And as you can see, once we do select all from to-dos, we will have 2 additional to-dos. So I can do select all from to-dos again. And as you can see, here are all of our entities. Okay, so we specified in our route that we are looking to get a to-do, and we should also pass it to our function. And then we can print it, for example. So let's do print ID. And now I will just send a GET request again. As you can see, now we managed to print the dynamic parameter we sent via our route. So this is our ID, which is 1. And now I can modify my query to use this ID. So I can do select all from to-dos, where ID is equivalent to our specified ID. So I can do this. Sorry, this is not the right keyword. I can do this and then specify our ID here. And now let's take a look at our route again. Once we did our GET request again, we selected a specific to-do, which is related to the ID we specified. So now if I'm looking to get, let's go here again, our second to-do, I can specify its ID and just do send. Back then we were talking about different HTTP methods. So as you can see, here we have the 4 basic methods. And here we are focusing currently on the get method, which allows us to retrieve data, to get data. Now let's say that I am looking to delete a specific to-do. I can copy this function again, but we should make sure that our functions have distinct names. So now I am going to do delete to do. So I will call it delete to do. If we have functions with the same name, we will get an error. So each function name should be unique. Okay, so I will change it to get to do's. And here I can do get specific to do. And I think that we are quite ready to move on. Okay, so we can now start working on our delete request. I can do delete from to-dos, where ID, and then specify our dynamic parameter. Here we specify that we are looking to use a parameter. So this is our symbol which represents our parameter, since that we cannot inject directly parameters here because this is a risk of SQL injection. So if I would specify ID directly here, for example, I can do it like this. Take a look. I can do it like this and then specify the ID, but this thing means that our API is not secured and that we can have an SQL injection risk. So if someone, for example, instead of a parameter is going to do drop table users, for example, and we have table called users inside of our database, it will work. And this is why you can never use raw SQL inside of your query. You should use this symbol, which makes sure to filter out any malicious code from our SQL statements. And here you can specify the ID or the variable you are looking to use. Okay. By doing this method, you are completely safe from any SQL injections and you shouldn't worry about it. This is the standard way, by the way, and let me overview this again. Delete from to-dos, where ID, and here we specify our ID. And sometimes, in those cases, we should do Postgres commit. In other libraries, you don't have to do it, but for certain operations such as removing, posting, and maybe updating, sometimes we should commit the changes. And then we can do this here because there is nothing to fetch. We just deleted an entity. So we can do entity deleted and specify the status code maybe. We can do to do deleted. And now let's try to specify a delete route and delete the first to do. Make sure that you specify a delete HTTP method. We should turn our API on again. API.py. Method not allowed. Why is that? Let's see. Okay. And here another mistake. As you can see, I forgot to change the method from get to delete. So let's do it. And now it should work. Make sure to specify the appropriate method here as well. And as you can see, we got our response. And now let's go into the database to see if everything has been working correctly. And as you can see, we managed to delete our first to-do. A quick tip in Postman, you can do what is called a collection. For example, you can do here a new collection, and then you can call it whatever you want. You can press here and do rename and do to-do collection, or just call it to-do API, and then you can save your routes. So in case that you are going to use them again in the future, you can save them here under your specified collection, and then you can call it whatever you want. So get to do. This function gives us all the to-dos, so I will change it to get to-dos, and then also the other function delete specified to-do, which is going to be under our to-do API collection. Okay, and now we can move on. Okay, so now I will show you how we can create new to-dos. So we can copy this and make sure to give this function a distinct name. So we can do post to-do. And you know what? We can change the route. You don't must to do it since that this route has a different HTTP method, but you can still do it if you want. Okay, so a method is going to be of a kind post. So this is our method right now. You should write it as a camel case post. And now I will show you how to retrieve data. I will just send a sample response and just show you how we can retrieve data from our API, from our request. First of all, I will specify the relevant route, which is this route. Hold on. Okay, so this is our route. And now we would love to specify just the title and the description for our to-do. So our title is going to be a post to-do, for example. And then our description is going to be post to-do description, for example. And now I will show you how we can get the data. I will comment this thing out and also this one. And then just show you how we can gather all the data together. So I can do data and then do request and call the JSON method on it. And then I will just print the data. Before that, we should make sure that our function isn't taking any unused parameters, such as ID. We don't use it anymore. In our route here, we don't even specify it, so we can remove it. So it won't be a parameter inside of our function. And now I will make sure to remove the brackets from the JSON here. We should just call it like this. And let's try to send a request. We got test. And as you can see, this is our data. So it is a dictionary. And then let's say that in order to get a specific entity, which is related to our data, we can do just a basic dictionary method. So I can do data get and then specify the keys. So I am looking to get the value for title, and here now I am looking to get the value for description. So I can do data get and then specify description. Now instead of printing the total amount of data, we can just print the necessary values we are looking to retrieve. Once we did this, now let's execute our request again. And as you can see, here is all of our values. And now we should insert them into the database. So let's do this. Cursor.execute, we should call the execute method, and then insert into todos, specify the columns, exactly as how we did here before with our insert statement. So we are looking to insert data into title and description, and then just specify our values. If we have two values, we should specify it twice. And then, of course, specify the variables we are looking to send, which are title and description. After that, we should do Postgres commit in order to insert the data. And then we can do here returning all in order to get all the data we have been inserting. So I will delete this line, and here I will specify the response. To me, it seems like we are all set and we can move on. And as you can see, here is our created to-do. Okay, now what if we want to update a certain entity to modify a certain to-do? Now we can do a patch request, which will allow it to be happening. Let's do select all from to-dos again. And let's say that I am looking to change to-do number 3. So I am looking to update its title. I can do update to-do. We specify the table's name, and then we can do set title. For example, modified to-do, where ID is equivalent to ID number 3, which is the ID of our third to-do. And now let's select it again. As you can see, here is the new modified to-do. So we can just do it in our API. So I will change it from post to patch. Patch allows us to change a certain entity inside of our database. And then I can just use the query. Okay, so I can do this, update to-dos. Let's say that we are looking to update the title. I can do that. I will remove the description since it doesn't matter now. Set title equivalent to this, which this is our dynamic parameter, where ID is equivalent to this as well. And here we should specify two variables. The first one is the title, and the second one is the specified entity ID. Okay, so now here we should accept an ID as well, and we should accept it inside of our function. And we can call it patch to do. Here we can also do returning all, which will return the new changes. So we can do returning all. And we can test it now. So as you can see, we specified our ID, which is the ID we are looking to update. In our case, this ID is ID number 3. And then we specified our new data, our new title. So now let's do select all from to-dos. The to-do is modified to-do. And let's try to change it to patch request test. As you can see, the request is working. We got our new updated data. Let's try to select all from to-dos again. And as you can see, we managed to successfully change entity number 3. Okay, another thing I would love to show you is that sometimes in the backend we have external processing. What does it mean? Imagine that you would want to do any processing in the backend after that each to-do has been sent. So now, in order to do this, we should call a function inside of our post request. So where is it? We can go to our post request. Just in theory, imagine that there are every calculations or any things you want to be running inside the backend in the background. So now, if we would call a function, we can maybe first declare a function. So I will first declare a function. I can call it every work. Imagine that this thing is some every work which is running inside of the backend. And then you can just, for example, I am just doing a simulation here, while true, and then I will increase the number by 1, and then I will print the number. So all I am doing here is just simulating a heavy work which might be running on the backend. On a real world use case, the function is going to be another function, of course, but this is just for simulation. And now let's say that we are looking to call this function. This function can even accept a parameter, just for an example. Specified title is, and then we can specify our title. Let's put a gap here. And we can wrap it with try and accept. Accept, exception SE, and print E. Okay, so this is our exception. It will print our error. And now let's try to call this function. So this function is going to run after we send a new to-do, after we post a new to-do. So we can call every work and just insert the title. Okay, and now let's see what is going to happen after this. So I can do Python api.py again. Okay, I will save this route. Also, post new to do. And now I will send the post request. So as you can see, we don't get a response. And why is that? It is because that our function is being used. And it doesn't leave any space for our API to send a response. And this is not good because this function is going to always analyze and run, as you can see here. But we don't want that our response is going to take forever. We should get a response after we send the data. It happens because that here our function takes the data and doesn't leave any time for our post to do route to send a response. In order to prevent this type of thing and make sure that our every work function stays in the background and doesn't interrupt our API cycle, we should use what is called threading. And I have a video about it as well in my channel. If you want, you can take a look. So then we can send a response and still use our function in the background without doing any bad things into the API itself, without interrupting the API. In order to solve this issue, we should wrap our function inside of a thread and call it in a different way. First of all, I should import the threading library. So I can do it from threading import thread, and then nest our function inside of a thread. So let's go to our route. Instead of calling this function like this normally, we should have a variable called thread and use the thread keyword with a camel case, and then inside of a target specify our function, which is every work, and then add another thing which is called args, which stands for arguments. So here we are going to specify our parameters. I will put it like this as well, inside of brackets. And to me, it seems like we are all ready. And we can start this thread. And those two lines will make sure that our process is going to be running in the background without interrupting our main application. If you want, you can read more about it, about the GIL, about multiprocessing and threading. Okay, so let's try to send a post request again and see what is going to happen. As you can see, we got our response immediately, and our function is running on the background. Okay, so now we can also access other routes as well. When we call it normally without threads, our function will block all the other routes and our API will not be servable and we will not be able to use our API. For example, on the newest version of Flask, each route is running inside of an isolated thread. But let's see what would happen if the case was different. So I can do threaded and then I can do false just to emphasize. And now I will run it again. Oh, sorry. Threaded. And now let's try to hit a post request. First I will do get request. And as you can see, our API is working. And now when we post a new entity, our function is going to run and block our API. So as you can see, we cannot access all the routes. No matter what routes we specify, we can't access because this function, this chunk of code is blocking the access to the rest of the API. Thank you for watching. This course was an introduction to backend web development with Python and Postgres with SQL. If you love this video, make sure to subscribe. I really appreciate it. I am going to upload new videos in the future as well, and I will see you in the next video.